class. Today we're going to be working on a review for the Solow Growth model for exam number 2. Now remember, the Solow Growth model has 3 parts. The first part is the productivity function. This is f of k. Remember, little k means capital per worker. The next part is the savings function. The savings rate, marginal propensity to save, multiplied by the production function. So it is a portion of what is produced is saved. The other portion is consumed. The third part is the spending function. So we have to spend on depreciation, we have to spend on population change, and different labor efficiency changes. And that is multiplied by capital per worker. Now remember, everything here is per worker. So if we have large Y, or product, or the production of everything in the economy, or income, divided by the labor of the economy, we're going to end up with little y, which is going to be production per worker, or GDP per worker. Next is the capital. So if we take the entire capital of the world, or of the economy, divided out by the labor, we will get the capital per worker, which is what we will be working with throughout this. So the one thing we need to know is, how do we get more capital? What happens when we start off below the steady state equilibrium to increase capital? We need to know the equation of motion. So remember, this is a change in capital per worker equal to the savings rate. So the savings is what is also invested, minus what we have to spend. So depreciation plus N plus G times K. So this is called the equation of motion. It is the addition of capital depends on the amount saved minus the amount spent on depreciation, changes in the population, and labor efficiency per person. So all of this is in per person. So remember, between the production and the x-axis, which is capital, this is what we have for our income, or what we produce in GDP. Between the savings rate and the production function, this is what we consume. And then below, between the x-axis and the savings function, this is what we invest. If it is above the spending line, we're going to spend this money on capital. If it is below the spending line, we're going to spend this money on depreciation, population changes, and tech growth. So from here, we could also do a few shifts. Now, we worked on the shifts in class quite a bit, so what I'm going to do is put up 2 separate problems, and then you could go ahead and work on them. Okay? So the first 2 problems we have on the board is what happens when savings decreases, and then what happens when depreciation increases. So looking at savings, we find it in the SF of K curve, or the amount saved in the economy per person. So if this decreases, what you'll do is shift the savings line down to SF of K2. This decreases the amount of capital per person in the economy, and thus decreasing the steady state. Now, when we're looking at depreciation, when depreciation increases, that means that we're going to be spending more of our investment on paying for what has rusted in the machinery or what has broken down. So what's going to happen is the spending line is going to tilt upwards. So here we see a tilt up to depreciation plus N plus G K2. And per person, the capital will decrease. So you'll see a decrease in the capital. Now, if depreciation decreases, then we won't need to spend as much on fixing and repairing the capital we already owned. So the line will shift the other way. Okay. Now, if you have any questions, just shoot me an email. There will be some of these on the exam. The next topic we're going to be talking about is the golden rule steady state. So in the Solow growth model, there are many different steady states that can be achieved. But we need to figure out which one is the best of all the steady state equilibriums. So we do this by thinking about what the economy needs the most, and happiness. But for us, happiness is consumption in economics. So what we are going to do is find out what part of the Solow growth model creates the most consumption. And that is where the production function and the spending on depreciation, population growth, and labor efficiency is parallel. And that's roughly about right here. Now, for us, we're just going to eye it out for this class. So, when we find where these two are parallel, we can see that at this portion, we are maxing our consumption, or C star, such that the production function subtracted by the spending will maximize the consumption. Below here is what we invest back into the economy through depreciation, population growth, or labor efficiency. So this is the spot where we want our savings function to be. So I mark this as the savings function G for golden rule. And here is where our steady state capital will be. K of G star. Okay, so just remember that the golden rule steady state uses the production function and the spending function to find where the best savings function would be. Okay? The final two topics we're going to cover in this review is how Solow has a balanced growth rate and also the factors of convergence and what that means. So the balanced growth rate means that an increase in the savings will only increase the standard of living and not change the growth rate in the long run. But in the short run, there will be a slight spike in the growth rate, but it will level out. This is because that a change in the growth rate permanently depends on a change in the technology growth, which for Solow growth model, we assume this is exogenous. So what happens is at first we're on the standard of living path number 1. So we're going along our growth rate, and then at time 0, the economy has a spike in savings. So when this happens, we see a jump in the short run in the growth rate until we reach the standard of living path number 2, which is parallel to the first. And then we level back off and continue on the original growth rate. So this happens because Solow assumes the technology growth rate is exogenous, so we can't change it. And that is the only thing that will cause a change in the growth rate itself permanently or in the long run. The next thing we're talking about is convergence. So pretend we have a rich country and a poor country, and each country gets allocated a certain amount of capital. So the poor country will be down here on the production line. So this will be KP1, and if we allocate X amount of capital to get to KP2, we can see that our output goes from Y1 to Y2. This is a large jump for just one unit of capital for the poor countries. But if we look at the rich countries, which are closer to having an equilibrium or being at the steady state equilibrium, and we give them the same amount of capital, KR1, and the same amount to KR2, we can see that the increase in output for the rich countries only changes a tiny bit, but for the poor countries there's a large jump. Now this is eventually going to allow the poor countries to converge towards the rich countries. And these are two different types of growth. We talked about these towards the very beginning of the Solow Growth Model section. The rich countries will have cutting edge growth. This is the growth that keeps them so close to the steady state equilibrium that a single unit of capital won't really improve their output very much. But on the other hand, for the poor countries, this is called catching up growth. So a single unit of capital will allow their output to grow dramatically. And as they continue gaining one more unit of capital, they'll be very quick in catching up to the rich countries. So if you have any questions with this review, please shoot me an email. I'm open most days, so just let me know. We're also going to have a Zoom review session right before the exam and on this coming Thursday. So let me know if you have any questions, and that's all for today.